How China is building the most high-tech country of the future. In 1964, a Chinese engineer set foot on the site of a hydroelectric dam for the first time. His job was simply to monitor the progress of the work. The country was destitute, filth everywhere, all the machinery Soviet-made, the workers shod in bast sandals. That engineer would write in his diary, "We are building this dam with our bare hands because we have no machines, no time, and no hope." Barely 60 years have passed, and this is no longer that China. There are trains here that fly without wheels at 600 kilometers an hour, stations out in the ocean and bases in orbit, factories where people are no longer needed, run entirely by robots. And here's the thing, none of this is some blueprint for the future. It already works. How is that even possible? Why do they have, in 2026, the very things other countries are only sketching into their concept papers for 2050? We are about to descend underground, venture into space, ride the train of the future, and then come back to figure out what year China is really living in. If someone had shown you photographs of the Tenga Desert as it looks today 10 years ago, you would never have believed it was the same place. Northern China, a place where the sand bakes to 60 degrees in summer and the temperature drops below -20 in winter. Nothing grew here for thousands of years, and now what grows here is electricity. This is home to one of the world's largest gigawatt-scale clusters of solar power stations, 10 million kilowatts of capacity. It's as if you plugged 1.5 million homes straight into the sun. And once the project reaches full capacity, 13 gigawatts, that will rival the entire annual electricity output of a European country. 43 square kilometers of solar panels, half of Paris, clad in bluish glass. From a satellite it looks like a giant lake in the middle of the sands, except this lake doesn't reflect the light, it gathers it. And what does it look like from above? It looks like a wall of technology sealing off the desert. No wonder they've already nicknamed it the Great Solar Wall. The panels here don't just harvest current. They hold back the desert itself. Grass has already begun to grow beneath them. The soil is turning moist, and the sand no longer drifts onward. On top of that, water evaporation has been cut by more than half. The solar farm has become a barrier against desertification, and energy and ecology have merged into a single project. But here's the interesting part. To carry the power from the desert, where only camels live, to the cities, they had to build a new ultra-high voltage transmission line. The main problem with solar stations in the desert is dust. Sand settles on the panels and efficiency plummets. So what do? Clean them with water? There's no water in the desert. The panels themselves carry a special nanocoating with a waterless self-cleaning effect that repels sand and cleans without a drop of water. No joke, they clean themselves. The project cost $12 billion, and this is only the beginning. China intends to build dozens of such bases in other deserts. Last year, the first phase was already connected to the grid, and the second is nearing completion. For thousands of years, Tenga was a blank spot on the map, and now it holds a power plant the size of a city. China has learned to see resources where others see only sand and problems. Xiong'an, 100 kilometers south of Beijing. Not long ago, this was a marshy floodplain and a handful of villages. And now they're building a city here that has 2 levels, one above ground and one below. Xiong'an is not just another Chinese city, it's a new metropolis being built from scratch as a city of the future. And in several layers at once. The underground level is nearly 50 kilometers of tunnels through which autonomous electric carts travel. Robots keep order, and pipes and cables run along precisely calculated routes. On the surface, only people and nature. It's a genuine underground metropolis where machines work instead of people. But what's it all for? Beneath the city runs a waste processing plant, 220,000 square meters, the size of 30 football fields. Every day it processes 3,000 tons of waste. The residents above don't even know that an entire garbage reactor is spinning away beneath their feet, because on the surface there's no smell, no pipes, no smoke. Emissions have been cut by 80%. And the trash bins on the streets, there simply aren't any. The waste is sucked away by a vacuum system straight from the buildings and carried underground through pipes. The city itself sits on a marsh, and the engineers turned that into an advantage. The roads are paved with porous asphalt fitted with sensors. And this is no ordinary surface. It soaks up water like a sponge. During a downpour, water drains through the channels 8 times faster than usual. A rainstorm that would flood an ordinary street simply passes straight through the road here. Along the way, the asphalt filters the water, trapping up to 90% of the dirt, heavy metals, and debris. All of it stays in the system and never runs off into the rivers. The Chinese call this a sponge city. It's been a national program since 2014. And the underground tunnels here are made of floating segments. If a flood comes, they won't collapse. The tunnels are designed to keep their integrity even when completely submerged. The city is already going up. State companies are moving in, and the first residential blocks are already occupied. And they went even further, creating a digital copy of the entire city. A full digital twin, updated in real time. City Hall runs the metropolis by watching its copy on a computer screen. The plans call for $580 billion in investment and 5 million residents. It's a city of the future that's already alive today. But even the smartest city is useless if it takes 3 hours to reach by car. What if you could travel between cities almost instantly? Shanghai and Hangzhou. Two metropolises, 150 kilometers apart. By car, that's 3 hours. On an ordinary high-speed train, an hour. But what if it took 15 minutes? Imagine, you board a train, and 15 minutes later you're in another metropolis 150 kilometers away. Not at an airport, not stuck in traffic, but right in the heart of another city. And this is no Hyperloop, the one Musk has been promising to start for 10 years now. This is being built for real right now, in China. The maglev, a train riding on superconducting magnets, at 600 kilometers an hour. That's 3 times faster than an ordinary bullet train, and only a little slower than a Boeing, which flies at 850 kilometers an hour. Only without the runway, the check-in, and the 2 hours at the airport. In testing, the train hit 623 kilometers an hour. To put that in perspective, that's literally half the speed of sound, a world record for ground transport. And it reached that speed in a matter of minutes. The acceleration is smooth but blistering. How does it work? The car hovers above the track on a magnetic cushion. Between it and the rail, there's nothing but air. Because of this, the infrastructure wears out far less. Inside the train, it's silent. The car is sealed, like an aircraft. Outside, the air roars at half the speed of sound, while inside you can talk in a whisper. An artificial intelligence system tracks the train's position to within a millimeter. No jolting, no vibration. Right now, the journey from Beijing to Shanghai, 1,200 kilometers, takes 5.5 hours. But once a line like this is laid, the train will cover it in just 2.5. Travel time will be cut by more than half. Yes, a plane is still faster, but by the time you drive to the airport, clear security, and wait to board, the maglev will already be there. The Shanghai-Hangzhou line is still in the design stage, but the train itself is ready. It exists, it runs, and it breaks records. By the way, just 10 years ago, the residents of Shanghai were protesting against the maglev. They feared the noise and the radiation, and back then, the project was frozen. Now everything is shielded, and the vibration is less than in a subway car. And no wheels. The track doesn't wear out, which means the line's lifespan is nearly eternal. But speed on Earth is only the beginning. There are problems a human being will never solve. Not because they're hard, but simply because they take too long. Modeling a planet's climate, calculating the interactions of billions of molecules in a new drug, processing the feeds from millions of cameras at once. That takes a brain that thinks billions of times faster than a human one. Say you're an ordinary person. You've been handed a problem. Model the climate of the entire planet 50 years into the future, across every parameter. Temperature, wind speed, humidity, oceans, the atmosphere. How long would that take you? Yes, a very long time. Now imagine it could be done in seconds, because that's what Tianhe 3 does, a Chinese supercomputer with more than 1.5 exaflops of power. That's a billion operations per second. Tianhe 3 is one of the world's first exaflop supercomputers. Write that number out and you get a 1 with 18 zeros after it. Officially, China doesn't enter Tianhe in the global rankings, but judging by the leaks and the indirect data, it's the most powerful computer on the planet right now. More powerful than America's Frontier, which holds the top spot on the public list. And here's the interesting part. It's built entirely on Chinese processors. Not a single Western chip. Each processor packs 16 general-purpose cores plus 1,536 accelerators on a single die. Effectively, it's a whole computer system in one chip. More than 50,000 of these nodes work together. And on top of that, record-breaking energy efficiency. The machine topped the World Graph 500 ranking for the ratio of power to consumption. And what exactly do they compute on this supercomputer? Aerospace simulations, nuclear processes, high-resolution climate models, for instance. And rumor has it that Tianhe can analyze the video from hundreds of millions of cameras simultaneously. And all of it in real time. Sounds like a dystopia? Wait until you hear about the mega project literally called Skynet. The exaflop was a threshold, a symbolic line everyone was racing toward, and China has already crossed it and moved on. No press releases, no ceremonies. But computing power is only a tool. The question is what exactly they do with it. For example, assembling hardware without a single human on the line. There was a time when people in China worked themselves to the bone. They stood at the conveyor belts for 12 hours, assembling iPhones, tablets, and other gadgets. Today, in those same factories, entire workshops run with the lights off. They simply aren't needed there. Welcome to unmanned production. A factory that runs in total darkness because its workforce is 40,000 Foxbot robots. That's right, its own fleet of industrial robots, assembling electronics with no breaks, no vacations, no shifts. The plant laid off 60,000 workers. They were simply replaced by robots. At the factories of Foxconn, the world's largest electronics maker, more than 40,000 robots now work in place of flesh and blood laborers. They solder, assemble, sort, and move parts between floors. Entire workshops run in total darkness, but the twist isn't only the robots. The new generation of factories is built vertically. It's not just a giant hangar, it's a multi-story plant. Hundreds of mobile courier robots ferry parts between floors, coordinating through a digital brain. Everything is managed like an anthill. No center, but with flawless logic. Before launch, it's all simulated in virtual reality. First, they built a digital twin of the factory, where every robot's movement is processed in a virtual environment, so that later, in reality, no one wastes time on setup. This saves up to 50% in both time and money. And now brace yourself. In 2025, Foxconn and NVIDIA rolled out humanoid robots. They'll assemble servers and plug in cables with their hands, just like a human. And a factory is already being built specifically for them. Thousands of such smart factories have already been certified in China. The state's goal is to automate 70% of all production by 2027. And in this equation, the human being is no longer the key link. But if robots watch over the production, then who watches over the people? 600 million cameras. One for every 2 adult residents of the country. This is not a dystopian screenplay, this is China today. The system is called Skynet. Except this version isn't hunting Sarah Connor. It's tracking 1.5 billion people at once. Cameras everywhere, in elevators, at intersections, on shop doors, on buses. But it's not about the number, it's about the brain. An artificial intelligence analyzes the video in real time, recognizes a face, produces a name, compares a gait, works out who it is, even under a hood. According to its developers, scanning the faces of all 1.5 billion Chinese takes a matter of minutes. It works. There was a case where a camera picked out a wanted man at a concert in Nanchang among 60,000 spectators. The artificial intelligence found him in minutes. He didn't even suspect he'd landed in the system, and they were already waiting for him at the exit. Here's the scale, in numbers. In the Chongqing district alone, there are 27,000 cameras for 600,000 residents. One camera for every 20 people. The system processes 4 billion images every day, and the citizens are actively drawn into the process. In rural areas, pensioners can tap into the local cameras through their television sets, flipping through the feeds just like TV channels. Spot something suspicious, hit the alarm button. Skynet is integrated directly into the social credit system. Crossed on a red light? The camera caught it. 1 bowl of rice less. Everything is linked. Face, passport, transactions, movement history. Now the system is being upgraded. The new generation of cameras carries an artificial intelligence chip on board. They recognize suspicious behavior on their own, without sending anything to a server. Of course, not everyone is happy with this, and it's easy to see why. But the fact remains. The system works, it expands, and it grows smarter every year. When the International Space Station is retired, only one inhabited object will remain in orbit. And it will be Chinese. Tiangong, the Heavenly Palace, the station China built on its own, without help from NASA or Roscosmos. 3 modules, a T-shaped structure, 100 tons of mass at an altitude of 390 kilometers. Since June 2022, the station has been permanently inhabited. 3 Chinese astronauts on board at all times. The crews rotate every 6 months. 1,000 scientific experiments have already been conducted. Materials, science, medicine in weightlessness, even attempts to grow crystals. The station is almost fully self-sufficient. Oxygen is produced from water through electrolysis, with 98% regeneration. Water is partly recovered from the air and the crew's urine. It's all a closed loop, the very kind without which you can't survive on the moon or on Mars. 5 robotic arms can crawl across the station's body on their own, moving to whatever module they need. They dock ships, hold cargo, and assist during spacewalks. By 2030, the station is to be expanded to 6 modules and 180 tons, with 6 people aboard at once. The docking ports are also to be expanded so the station can receive several ships at the same time. And here's another interesting fact. Alongside Tiangong, a separate telescope will fly, Suntian. It's a 2-meter mirror with a field of view 300 times wider than Hubble's. And crucially, it can dock with the station for repairs and upgrades. Even the ISS had nothing like that. China is already inviting foreign astronauts. Pakistan has signed an agreement, and its astronaut will fly aboard Tiangong within the next few years. We are watching China become the leader in the space race. Paradoxically, we know more about space than about what lies hidden beneath the water. But China is getting ready to fix that. 2 kilometers underwater, pressure 200 times greater than atmospheric. Eternal darkness and a temperature near 0. There, on the floor of the South China Sea, China is building the world's first permanent underwater station at such depths. 6 aquanauts, a long-term expedition, an autonomous life support system. Essentially, it's like Tiangong, only underwater. Yes, straight out of science fiction, except not on paper. The project has already been approved and has moved to implementation. The main question, why does China need this? Beneath the mass of water lie real riches, and it's for their sake that China is willing to take such a risk. cold seeps, places where methane escapes, and deposits of flammable ice, crystals of methane hydrate that could become the fuel of the future. To study and extract them, you have to be right there. The engineering challenges are, in fact, harder than those of space. Regenerating the air under monstrous pressure, a system for disposing of carbon dioxide, airlocks for exiting into underwater vehicles. All of it is in development right now, but a base on the seafloor is only part of the plan. In parallel, China is designing a floating platform called Island. 86,000 tons, heavier than the largest aircraft carrier in the world. Dimensions of 138 by 85 meters, a crew of 238. This platform can stay in the open ocean for up to 4 months without any resupply. Essentially, it's a mobile underwater city. And here's a detail that astonishes even the engineers. The platform's hull is made of an alloy with a negative Poisson's ratio. In an explosion, it doesn't tear apart. It contracts. The structure will withstand the shockwave of even a nuclear blast. And typhoons and hurricanes are just routine weather for it. The deep sea station will be ready by 2030. The floating island by 2028. And along the coast, a great underwater wall is already at work. A network of hydrophones and drones with which China intends to track everything that moves beneath the water. Space, sky, land, and now the ocean too. China is mastering the planet layer by layer, but there are spaces where distance means nothing. That's a vacuum. The ocean floor is 2 kilometers down. From Beijing to Shanghai, it's 1,200 kilometers across. China has found a way to shrink that distance to an hour and a half. All you need is a tube and a vacuum. And if the high-speed maglev impressed you, you're really going to like this. When Elon Musk in the US was only just announcing the idea of the Hyperloop, the Chinese had already begun building the same thing. An enormous tube with almost nothing inside. Pressure below 1/100th of an atmosphere. So little air that there's almost no resistance. And inside that tube, a capsule on a magnetic cushion. The idea is simple. The capsule hovers on a magnetic cushion inside a tube where there's almost no air. Friction, zero. Resistance, nearly zero. Which means you can accelerate to a wild speed with minimal energy. In 2023, the T-Flight prototype hit 623 kilometers an hour. Over a stretch of just 2 kilometers. That's already faster than any train in history, including the Japanese maglev. But this is only the first phase. And the goal of the second phase is 1,000 kilometers an hour, nearly the speed of sound. For speeds like that, they had to solve problems that simply didn't exist before. For instance, how to maintain a vacuum in a tube tens of kilometers long. And here, the Chinese found a brilliant solution. Automatic pumps and sectional airlocks that seal off a segment at the slightest leak. How do you brake if the magnets fail? Simple. Gas generators instantly fill the section with air, and an air cushion brings the capsule gently to a stop. Right now, a 60-kilometer test track is being built. On it, capsules will be accelerated to more than 1,000 kilometers an hour. But the Chinese decided not to stop even there. For Phase 3, they plan to accelerate to 4,000 kilometers an hour. That's already a third of orbital velocity. Beijing to Urumqi, 3,000 kilometers across all of China, in just an hour. Elon Musk's Hyperloop began with a splashy presentation in 2013. 13 years have passed, and there's still not a single working line. China's T-Flight began quietly. No magazine covers, no fanfare, no presentations. But at some point, a capsule accelerated to 623 kilometers an hour, and the technology already works. By the way, the project is run by the very same corporation that makes ballistic missiles for China. These are the same people who arm the Chinese military, and the same technologies. Only now they're for civilian transport. Some 15 years ago, all of this would have been science fiction. Today, it's just another line in the reports of Chinese corporations. You can argue about the methods, about the price people pay, and about where total control leads. But one thing can't be denied. China is no longer the world's factory. It's the planet's engineering vanguard. Stations in the desert, stations in orbit, stations underwater, factories without people, cities without wires, trains without air. Ignoring Chinese technology is no longer an option, because if you want to see what 2050 might look like for the rest of the world, just look at China in 2026. To be continued.